So finally, let's take another look at this graph here. The data over here is obviously from a couple seasons. The two seasons are 1981 and 1994. These two seasons are strike-shortened seasons. Major League Baseball went on strike. And so what happened is there were less games in the season. So the problem with this linear weights estimator was I added a constant average runs that worked for the whole data set. These team seasons played significantly less games. And when I added the plus 701.2 runs to the linear weights formula, which is a reasonable way to improve the formula to make it more in line with other linear weights estimators, other runs estimators, these seasons were off. It created a higher runs estimate for the seasons with strike shortening. That's obviously what happened. I just want to explain that for the student. Now, beyond that, remember it all starts with FC Lane. He does his own version of looking at events, singles, doubles, triples, home runs, walks even, looks at those events and puts run values on events. Run values on events. That sounds a lot like that whole effort following that of runs estimator, run values on events. And his numbers aren't too far off from the numbers seen in Pete Palmer's work. Pete Palmer simulated games for almost a century. A lot of games and situations were simulated to come up with Pete Palmer's run values on events in his linear weight system. And same thing with Furtado. And others who were like Furtado, creating linear weights formulas, used various techniques, simulation, multiple linear regression, looking at run scoring situations in the base out states. Various techniques have been used to get at run values on events in the whole class of runs estimators called linear weights. Linear weights runs estimators. So that we looked at some of those in the previous video segment, and they're pretty good. They work pretty well when we look at team runs and linear weight runs. As an exercise for the student, you can go ahead and try and run the same SQL queries without these years. Bring them over to R, run the R code provided to see if you can get a better correlation with linear weights than we showed in the previous video. This is an exercise for the student, and I'm sure a lot of our students can figure out how to do that because they're getting better and better at SQL code and manipulating data within R. So that's my challenge to the students, that they go ahead and do that and discuss it further on the discussion forums for Sabermetrics 101, for Saber 101X on the edX platform. Now, linear weights isn't the only way to estimate runs. Bill James did his. Now, this is not based on linear weights. This is based on this idea of getting on base, advancing runners on base, divided by opportunities. Now, other people have done the same thing, not by trying to get at run values of events in the average case, trying to model how runs are actually scored by how they actually happen in a game, similar to what Bill James tried. And probably the best version of this is something called base runs. Base runs. And it's abbreviated all over the place as BSR, base runs. Now, David Smith created base runs, and his last name is spelled with a Y. So David Smith came up with this whole idea of base runs as a way to estimate runs. And theoretically, he starts in a different place. This is later, after all the work done by Bill James and the work done by Pete Palmer and all the other folks who did linear runs estimators. Now, there is a lot of sturm and drang around these issues. Which is better? Which does a better job? And a lot of times, if you read more into this, people are very protective of their own work, thinking it does really well. Context matters. If I choose different seasons, I seem to change the parameters, the coefficients to the linear weights formulas. Base runs takes care of that. Linear weights has to adjust based on context. Not a whole lot. It's very small adjustments, but to improve accuracy, you have to change the coefficients based on run scoring environment. But you gotta ask yourself, every sabermetrician, every student of this area have to ask themselves, what do you want the runs estimators for? If you're an advanced student who really wants to understand advanced theory in sabermetrics, you probably want to look very closely at base runs, BSR. It has an improved model for how runs are scored. It's not just using average values over certain run scoring environments. So if you're just looking for a nice simple formula to better understand this basic concept of runs estimators, say you're a beginning student or a beginning sabermetrician, or you really don't care about the theory as much as whether something works pretty well, then you can use many of these runs estimators because they're all about the same accuracy. Base runs trumps the other runs estimators because of its theoretical underpinning and its flexibility across many different run scoring environments. Because it's sound theoretically, it works better in low run scoring environments, high run scoring environments. It would work in softball leagues where runs are 15, 20 a game. It would work in pitchers leagues where you hardly score any runs. It's theoretically sound across all different run scoring environments. In other words, Smith goes about it saying, hey, how are runs created? Now, Bill James did something similar here too. You got to remember, Bill James went about it by saying, how are runs created and how can I build a formula that estimates it? And he got pretty close. And then he spent many, many articles writing about variations of this very simple formula to improve it and make it more accurate. And Smith, just like James, starts off with a very good theoretical underpinning for his choices of base runs, the choices he makes. So if you're a sabermetrician who's new at this, I would suggest that you try to understand this whole category of runs estimators. They're fairly accurate within the range of where the game is played. But if you're going to be modeling the game more completely in different run scoring environments that may change potentially, if you're modeling things broadly for whatever might happen to your team in terms of run scoring environments, reduced or increased run scoring environments. So it really comes down to, what do you want the runs estimators for? They really all seem okay within this certain range of how Major League Baseball is played. We're really teasing out some differences to say one is more accurate than the other. They really do a nice job. Now remember, though, that a lot of these are built on the average situation. Linear weights is based on average situations. And when you change the situation, you've got to change the coefficients on the linear weights. You change the run scoring environments, etc. So that's my take on runs estimators. It really depends on where you are. Do you care about improved accuracy and the improved theoretical underpinnings of base runs?